There will be significant economic consequences from the collapse of that bridge linking Seattle with Canada this past Friday. The route carries $1 billion in freight every year, and it could be weeks before there's a temporary fix. And the National Transportation Safety Board is sounding the alarm, calling the collapse a wake-up call for America's aging infrastructure. Our guest today is Casey Dinges, who is a part of the American Society of Civil Engineers, and joins us to give us some perspective on this bridge collapse as well as what's happening across the country. Casey, thank you so much for being here with us. I do appreciate it. So what we've learned since Friday's collapse is we already knew that the truck hit the structure that caused the collapse. Is this something that many bridges across the country are in danger of?
I would urge a little caution at this point, saying what caused the collapse. Certainly, what appeared to be an oversized truck may have hit one of the bridge members overhead, initiating this collapse, but it really is too early to tell. I would give the NTSB the time that it needs. This was a 68-year-old bridge. It was also a functionally obsolete bridge. There are a number of, I think, different factors that the NTSB will be looking at. But I think it is good to, I think, call people's attention to the condition of the nation's bridges and infrastructure, for that matter. It has been neglected for far too long. And unfortunately, it's incidents like this that captures the public's attention and seems to get things moving. I think we're most fortunate there were no fatalities in this incident. We did release a report card on the nation's infrastructure in March of this year, and we looked at a number of 16 different categories of infrastructure. Bridges was one of those areas. Actually, there had been a modest improvement in bridges overall across the country. From a C to a C+. The total number of deficient bridges had actually gone down in the last 4 years, so there was some marginal improvement there.
Well, that's a little bit of good news, but can you sort of qualify how bad this problem is nationwide? Is there a percentage or a range that you can give us in terms of how many bridges that are suspect that need updates or perhaps need to be replaced?
Sure. There are a total, just to give you some big round numbers, and I'll do a little rounding here, there are about 600,000 bridges in the United States, and of those, about 1/4, or 150,000 bridges, are considered deficient in some way. And then when you look at that number of 150, it breaks down into two categories. Bridges that are structurally deficient, there's about 65,000 of those, and structurally deficient means there's certain age, decay, degradation, and wearing down that has occurred on those bridges. And then there are another 85,000 bridges that are classified as functionally obsolete. And those are bridges that are structurally okay, but they are bridges that we wouldn't design in this day and age. In other words, the lanes might be a little too narrow, the shoulders might be narrow or not have shoulders at all. There might be low clearances on the bridge that can't accommodate modern truck traffic. So functionally obsolete means a bridge that we would not design in this day and age. In this case, the I-5 bridge was a functionally obsolete bridge, but it was not a structurally deficient bridge. So that's kind of the big picture on bridges. And you mentioned in the lead up the critical part of trade between the U.S. and Canada of that I-5 bridge. And from what I understand, I think there's a 1-hour workaround. So any one of the 70,000 cars and trucks per day that go over that bridge are now adding at least 1 hour to their drive time.
Indeed, and I'm so glad that you brought that up, because all the traffic is diverted to other bridges. And as I read, they're in smaller communities, which make me wonder, are those bridges that are now receiving the overflow, if you will, from the traffic that would normally go across this bridge, are they put in jeopardy because now all of a sudden they're getting more weight, getting more traffic than perhaps they were built to withstand?
That's a good question, and I can't say specifically in this case, although going back to the discussion about structurally deficient bridges, when the engineers believe that the use of the bridge has to be changed because of structural degradation or age, they will do what's called post the bridge. In other words, a sign will be put up showing what size vehicles are perhaps prohibited from using that structure, and what loads or weights are limited to use on that bridge. So it is possible that there could be other problems for certain heavy loads if they encounter a bridge on one of these off-roads that has restrictions. So that is a possibility.
Indeed. I also read that with that particular bridge, there was a height limit of 14 feet. I want to say maybe 6 inches. The truck that went across was 15 feet and some change, and there was no sign indicating the height limit. Is that a common problem around the country, poor signage or lack thereof?
Can't really comment on that. The one other thought, though, I can add to what you just said is remember, this is a 4-lane bridge, so you have 2 lanes going in each direction. On the outer lanes, I think the height limit was in the 14-foot range. On the left-hand or inner lanes, the height limit was actually 18 feet. So, and that's because there was an arch as part of the structure on this bridge. So if you can imagine that, you can see how in the outer lanes there would be more of a height limitation than on the inner lanes where the arch is higher. So, again, this is something the NTSB will be looking at. I mean, it's all speculation at this point, but perhaps the driver was just in the wrong lane. We'll have to wait and see.
Sure. Casey, in general, how often are our nation's bridges supposed to be inspected as opposed to how often they actually do get inspected?
Bridges get inspected every 2 years in this country unless they've been rated structurally deficient, and in that case, the bridge will be inspected at least once a year.
And if we were able to fix all the bridges that either need to be updated or replaced because they're functionally obsolete, how much money are we talking about here?
The numbers that ASC has in our report card, and these come from the Federal Highway Administration, we're looking at a current gap right now of about $8 billion a year. So we're spending about $12 billion. We need to be spending about $20. So if we were to up that spending level by $8 billion a year, between now and the year 2028, according to Federal Highway, we could eliminate the backlog of deficient bridges. So $8 billion is a sizable number every year, but in terms of an overall GDP in the United States of over $15 trillion, it certainly would seem like a very doable challenge for the United States.
Indeed, but in this day and age where, we're going through a sequester and all of the things, the question is, where does this money come from? Should the average person who's driving across a bridge be afraid today?
No. People should not be overly alarmed by this. I think one of the reasons this is news is that it's actually such a rare occurrence, having this kind of situation occur in the United States. But it's not just a safety issue, bridges. These are, critical economic lifelines for the country. The bridges, connect the highway system in this country together, and that system really does move the U.S. economy. I will add that Congress will have a chance in the coming year to deal with this entire surface transportation issue. The current law expires at the end of September 2014, and that is also about when the current Highway Trust Fund, which is where all the user fees are collected for federal spending on these programs, that trust fund will go bankrupt. So Congress is going to have to do a very heavy lift next year on the transportation reauthorization bill.
Casey Dinges, who is the Senior Managing Director at the American Society for Civil Engineers. Casey, thank you so much.
You're welcome.